All in this video we will see array of pointers. Okay, this question is taken from GATE CSE exam. So here is the question. Consider the following C program, right? We are given an integer array and it is initialized with these values. Okay, so let us see the memory representation for this array. So here is our array A and it contains 5 elements. And the elements are 10, 20, 30, 40 and 50. Okay, let us say that the starting address is 1000. Okay, so assuming that integer requires 4 bytes, the next integer is stored at 1004, 1008, 1012 and 1016. Okay, then we are also given an array of pointers which is initialized with these values. So let us see that array of pointers. So here is the array of pointers. This also contains 5 elements. Okay. What is stored over here is A. So A will give you address of its 0th element. This is the 0th element of the array and its address is 1000. So it is copied over here 1000. Then A plus 3 will give you address of the third element, right, which is stored over here. Then the next initializer is A plus 4, which will give you address of A of 4 and the address is 1016. Then A plus 1 will give you address of the first element, which is 1004. And finally we have A plus 2, which will give you address of the second element of the array, which is 1008. Okay, let's also assume that the starting address of this array is 2000. Now on a 32-bit machine architecture, storing each address requires 4 bytes. So the next address is stored at 2004, 2008, right? '60. Then we have this double pointer PTR, right? So there is PTR. What it contains is P, and when you write P, you get address of its 0th element, right? And the address of the 0th element of P is 2000, so you get 2000, right? Okay, now we have a simple statement says that you should increment the value of PTR by 1. So PTR is incremented by 1, so 2000 plus 1, right? That's what we want to do, right? We wish to know what is 2000 plus 1. Now in reality 2000 is an address which stores another address. Okay, 2000 is an address which stores another address, and storing address requires 4 bytes. So when you add 1, you add 4, right? So 2000 plus 1 is 2004 because 2000 is an address which represents another address and storing address requires 4 bytes. So 2000 plus 1 is 2004. So this value becomes 2004. Okay. Now we are printing two values over here. The first value we wish to print is PTR minus P. Okay, now you know what PTR is. PTR is 2004 minus P. P means you get address of the zeroth element, which is 2000. 2004 minus 2000 is not 4 because 2004 and 2000 are addresses, right? And those addresses represent addresses, and storing address requires 4 bytes. So basically 2004 minus 2000 is the range of addresses gives you 4, right? But in 4 bytes, so this is the range which you get 4 bytes, but in 4 bytes how many addresses you can store? Why I am saying addresses? Because 2004 also stores address, 2000 also stores address. So we check in 4 bytes how many addresses can be stored, and storing one address requires 4 bytes, so you divide it by 4, so that's 1. Okay, so the first output is 1. And next we are simply printing star star PTR, right? Star star PTR. So you know what PTR is. PTR is 2004. A star on that will give you a star on 1012. Value at address 1012 is 40. So the next output is 40. So this is the output of the program. I hope you have understood this. Thank you.